Okay, so this is the problem with the gravity problem, and so the goal of this problem is to use gravity between the Earth and the Sun to calculate how long it takes the Earth to go around the Sun. Okay, so the first part of this problem, we want to know the acceleration of the Earth due to gravity from the Sun. And so basically Newton's second law tells us that F equals ma. So the gravitational force from the Sun on the Earth causes the Earth's centripetal acceleration as it goes around the Sun. So this would be mass of the Earth then, times the Earth's acceleration due to gravity from the Sun, which is also the centripetal acceleration. Okay? Now the force of gravity, we know, is G times the mass of the Earth times mass of the Sun divided by the Earth-Sun distance squared. Okay? So the Earth's mass cancels out of this expression. And we're left with the acceleration as g times the mass of the Sun divided by the Earth-Sun distance. So the acceleration then is g, which is 6.67 times 10 to the minus 11, times mass of the Sun, which is 1.99 times 10 to the 30. And I'm going to skip writing the units in. And that's okay, just as long as we know that we're using the right units. So this is kilograms, so we want to use the Earth-Sun distance in meters. Now the Earth-Sun distance in kilometers is 1.5 times 10 to the 8. So in meters, it's 1.5 times 10 to the 11 meters. You've got to make sure we have all our units straight before we start plugging things in. Okay? And the answer you get when you do this calculation is 5.9 times 10 to the minus 3, and that's in units of meters per second squared. Okay? So that's the acceleration due to gravity felt at the Earth from the Sun. Therefore, that is Earth's centripetal acceleration as it goes around the Sun. Because the Earth is essentially, as we've seen, it's for orbits, the Earth is basically in free fall as it goes around the Sun. So this is the Earth's centripetal acceleration then. And then in part B, we want to use that centripetal acceleration to calculate the Earth's angular velocity. Okay, the relationship between centripetal acceleration and angular velocity is it's omega squared times r. Okay, times this is the Earth-Sun distance here. And there's our centripetal acceleration that we calculated in part A. So the angular velocity is then the square root of the acceleration divided by the Earth-Sun distance. Okay, so we plug that stuff in. The acceleration is 5.9 times 10 to the minus 3 meters per second squared. The Earth-Sun distance, again, is 1.5 times 10 to the 11 meters. And you do this calculation, and you get the number 1.98 times 10 to the minus 7. And that is in radians per second. Okay? Now, in part C, we want to calculate the angular velocity in terms of revolutions per year. So we want to convert radians per second to revolutions per year. So our angular velocity is then it's 1.98 times 10 to the 7 minus 7. And that's radians per second. So we'll first convert to revolutions. So we have to divide then by 2 pi radians for every revolution. So the radian units will cancel, and now we have revolutions per second. Okay. Now we need to get this into revolutions per year. So we need to figure out roughly how many, well, exactly how many seconds there are in a year. So to do that, we first are going to convert to hours. So there are 3,600 seconds in an hour. So the seconds cancel. We now have revolutions per hour. There are 24 hours in a day. So the hours cancel. We now have revolutions per day. And there are 365 days in 1 year. Okay? So days cancel, and we're now left with revolutions per year. So you have to do this multiplication, 1.98 times 10 to the minus 7, divided by 2 pi. So that's 2 pi in there. It's kind of hard to see that. Times 3,600 times 24 times 365, and that gives you the angular velocity in revolutions per year. And the number I get when I did this was 0.994 revolutions per year. Okay? So we know what the real answer is. The real answer is 1 revolution per year. So basically, within the precision of these numbers here, I mean, really 365 days per year, it's really 365 and a quarter days per year. So at least to the precision with which we used all these numbers here, we got the right answer of 1 revolution per year. And so we arrived there by starting with gravity. Basically, using the force of gravity between the Earth and the Sun, we used the acceleration we got from that answer as centripetal acceleration. That implied a certain velocity, which is 1 revolution per year.